Okay, today we're looking at the Fibonacci sequence, a famous mathematical sequence that was named after an Italian mathematician or Roman mathematician, Leonardo di Pisa. Lucky. So we've got the numbers. You can see at the top 1, 1, 2, 3, 5, 8. So what's happening? It always adds the next number is also the sum of the previous two numbers. Okay, and we have to start at the third sequence. Okay, well technically we start here because that is the sum of 1 and nothing. 1 and nothing is 1. 2 is 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So have a think, what do you think the next number is going to be? We have to go 8 plus 13 and we get 21. Then we go 13 plus 21 and we get 34. So we're always adding the previous two numbers to get the next. So the next one is going to be 55. Okay, so Fibonacci sequence, add the previous two numbers. So we'll have a bit, we're just going to explore the Fibonacci sequence a little bit more. And we've got the rabbit breeding problem. The Fibonacci sequence is a sequence of numbers that occurs quite often in nature. If you have a look at some pine cones, the number of little shapes around a pine cone, if you count them in one row and go up to the next, that's part of a Fibonacci sequence. Okay, so if you can count 3 rows on a pine needle, you'll find that the third one equals the sum of the previous two. So this is the rabbit problem, the rabbit breeding problem. So at the start of the second month, they mate. Okay, so they're born and after 2 months they mate. At the start of the third month, the female produces a new pair of rabbits, one male and one female. So we've got a pair of rabbits. Month 1, we've got a pair of rabbits. And month 2, we've got the same pair of rabbits, but at the start of that month they mate, and at the start of the third year they breed a new pair of rabbits, one male, one female, nicely colour coded. Males are blue, females are pink. Okay, so now we've got 2 pairs of rabbits. Okay, so at the start of the 4th month, the older female produces a new pair of rabbits, one male and one female. And we end up with 3 pairs of rabbits. And then at the start of the 5th month, we've got the next pair of rabbits start breeding, and we end up with 5 pairs of rabbits. Okay, so we've got the rabbits are breeding in a pattern that matches the Fibonacci sequence. Okay, so that's one place where we can see it in nature. Okay, petals of many varieties of flowers have a Fibonacci sequence, and like I said about a pineapple, a pine cone. So a pine cone has 8 spirals in one direction and 13 spirals in the other direction. So Fibonacci sequence went 5, 8, 13. So that's part of the Fibonacci sequence. So it is a very interesting sequence that we see in nature quite a bit. Okay, let's have a look at some terms in the Fibonacci sequence. Okay, so we've been told that T10 is 55, T11 is 89. We've been given that information. We want to find T12. So to find T12, which is part 8, to find T12, it's just going to be the previous two numbers, 55 plus 89, so T12 is going to equal 144. So these are set numbers in the sequence. Okay, to get part B, T8 plus T9, we're just working backwards. So term 10, so T at term 8 plus term 9 is going to equal term 10. And we know that term 10 is 55, so that's just going to equal 55. Okay? And the last one, the last bit of the example, term 13. So term 13 is going to be term 11 plus term 12. So it's going to be 89 plus 144. Okay, 13th term is the 11th plus the 12th one. 89 plus 144, so it's going to equal 233. You can see down the bottom of page 402, they've actually generated the Fibonacci sequence. Term 1 is 1, term 2 is 1, term 3, we add the previous two, term 1 and term 2, and we get 2. And it shows you the way it's generated. And the rule for the Fibonacci sequence is T of n equals Tn minus 2 plus term n minus 1. So that's the previous term, and that's the one before it. Term n minus 1, term before n, and n minus 2 is 2 terms before n. Okay, so that's the general rule for the Fibonacci sequence. So if we're going to write out the Fibonacci sequence, we have term 1 equals 1, term 2 equals 1, term n equals term n minus 2 plus term n minus 1. So that's there is the Fibonacci sequence. I want you to make sure you copy this bit into your bound reference. Okay, example 27 looks at another sequence. This one's called the Lucas sequence. Okay, so the Lucas sequence has term 1 equals 1, term 2 equals 3, and the next term is the sum of the previous two terms. So it's the same sequence. Okay, this bit here is exactly the same as the Fibonacci sequence. The only thing that's different is term 2 is different. It's 3 instead of 1. So we're going to do the first 5 terms. So term 1, term 2, term 3, term 4, term 5. Now, we just need to interpret what this actually means. It just means we're adding the previous two terms. So term 1 is 1. We're given that. Term 1 is 1. Term 2 is 3. That's just given to us. Now to get to term 3, we have to add the previous two terms. 3 plus 1, or 1 plus 3 is 4. Term 4 is going to be 3 plus 4, which is 7. And term 5 is the previous two terms. 4 plus 7 is 11. Okay, so the sequence goes 1, 3, 4, 7, 11, and we'll keep going. Next term will be 18, etc. Okay, not a real lot. It's just a reasonably simple sequence. I just want you to get the terminology today. That's the main thing. Just add the previous two terms. You can try this one, just read through this one. So come back, pause the video, or if you want, it's on page 404 of your book. Okay, I'm not going to cover it, but you can just read through it. It's just a maths trick that you can try, and try it on someone at home, or if you've got a friend here, just do it in a pair together. But today you're working on exercise 8A, page 404, and that's the last chapter of the text before we go on to the review chapter. Okay, once again, if there's something in there you don't quite understand, just ask for help, and I'm happy to help you on Teams chat. Otherwise, all the best, and I'll catch you in the next class. Thank you.